Okay, the first thing we're gonna start with is stage and layers. If you want to work with a stage, you need to understand how it's made. The way you can think about it is by using the analogy of tracing papers. If you remember in Iron Man, when he has all those tracing papers put together, they don't look like anything really, but then once they are all composed together, you get the final Iron Man suit. Well, it's basically the same thing when it comes to the stage. The stage by itself is just a lot of different layers put together, composed, and you get your final result. Now, there is a pretty big nuance to it, and it's the fact that when it comes to tracing paper, all you're doing is adding on top of whatever exists already. USD, on the other hand, have the ability to affect whatever came before. Meaning, when you add a new layer, this new layer might change whatever content was under it, which makes it really powerful. Why? Because it's non-destructive. Meaning, if you had a layer that has something in it, and you had a new layer on top of it that is changing this something, if you were to remove this layer, then you go back to the original state of the first layer. So it's really powerful, but it also depends on how you work. You can choose if you want to completely override the first layer, but in the meantime, if you wanted to, you could just do every step of your development using a new layer every time. Now, usually you don't do that because that would be extremely heavy and messy, but just be aware that's how you could work if you wanted to. Okay, so first thing first, let's talk about how you create a USD. What I've done here, I've created a primitive cube, beautiful cube, and I'm exporting two files, USDA and USDC. Now the difference between USDA and USDC is one is binary and the other is readable. So if you look at it, the USDA, as you can see, I can read it, definition cube hello world. USDC is a binary format, so I can't read it. USDC is later, but it takes longer to read. So if you end up with really huge scene, in some cases it might be better to use this format instead. Although this format is gonna take more disk space, so it really depends on your usage. You will probably encounter both. The last format that I'm not gonna cover is USDZ. It's kind of an archive format, so you probably are not gonna see it very often. The only reason really why you would see it is if you have to send something or you receive something from a client. Okay, so let's start with how you make your layers. So whenever you create a USD, you have the choice of adding your primitive directly on the root, or you can add it as sublayers. So what I've shown you here with this example is adding them directly in on the root. So if I check my scene graph, if I load back my file, you will see that I simply have the definition cube directly in here. That's the first way, the most simple way. It's on the root, there is only one file, and that's the one that I'm using. On the other hand, what I could do instead is not saving my primitive directly into example A. I can use the configure layer node to save an intermediate layer. So I'm gonna call this layer A. I'm gonna save this. And when I load this back, you will see that my stage is exactly the same, but the difference now is that I don't have my cube directly on my root. It's now a sublayer, and the sublayer is layer A and the cube is on layer A. So as you can see, the idea is really just, do you want to have your elements directly on your root, or do you want to have a sublayer instead where the elements will live? You can have both living together. So for example, what I've done here is I've created a layer A, I've created a layer B, a cone, putting all of them together and saving this into example A. When I load example A back, you can see I have all of them living together, so they are all composed together, and it's made of the two sublayer A and B, and my cone living on the root. So layer A has the cube, layer B has the sphere. That's composition. So basically it's taking everything there is, the layer and the root, put them together, and it creates my stage. Now be aware, when it comes to composition, we'll talk about this later, but having opinions on the root, it's stronger than having opinions in sublayers. Now be aware too that you can sublayer anything. So the fact of creating a sublayer doesn't mean that the USD file is going to be different. It's just a normal USD. It's the way you use it into another USD that's going to influence how it appears. So if I take my example A right now, which use sublayers, and I save this into example B, I'm bringing this as a sublayer right now. So if I save this one and load it back, you will see that now my example B has one sublayer, example A, and I can go through the layers now and I'm back to layer B, layer A, and my cone. So you can have as many sublayers as you want. That's also the reason why when you create a file, it's gonna ask you, do you want to bring in as a sublayer or as a reference, which we are gonna talk about later. Just to show you, what I've done is I've created a layer C for my cone. So now if I save and I will load my file, you will see that I have now only sublayers, one for each one of them. On the other hand, I could absolutely remove all of this and save this, reload, and you will see that I have now 0 sublayers. All I have is my definition in the root. So yeah, it really depends where you're working. Have a look at the structure that is expected and it's gonna greatly help you. One thing you've noticed that I use this UI here. Basically what this UI does is it's reading the USD file. So if I were to open the USD file in my folder, it will look exactly the same. I will use this a lot because with USD, it's really important to be able to read the file directly. It will really help you when you have to debug USD, so I will try to use this as much as possible. I know it looks like the matrix, but it's really not that hard. The thing when it comes to USD is that what you see is what you get. So what you see here is actually my file, it's my USD. So if I open the USD file, everything that is happening and the stage you saw is this. So whatever I change here is gonna affect my stage. So if I take this here, change it to cube, save, and reload here, now I have a cube. So that's why it's really important to understand how this works. So I've talked about layers, but what I also explained earlier is that you can do overrides in layers, and layers can override each other. So far what I've done is one layer that have a content and another layer that have another content, but it's not really showing this override part. So what I'm gonna do is I'm gonna create a new layer that is just an override. Here, I'm gonna make a transform of my cube, as you can see here, and I'm gonna save this as layer A over. Gonna save to disk. And now when I reload, you can see I have my cube transform. Now, if we were in any other pipeline, you might expect that the cube transform is now part of the file in the sense that it's baked, basically, but not in USD. And if you check the layers, you can see I have my layer A that creates my cube, and then my layer A override creates an override of the transform. What this means too is that if I want to, I can mute my layer override. And by doing so, my cube goes back into position. So as you can see, it's non-destructive. So it's very powerful because anyone can add a layer of modification on top of another asset and don't take the risk of basically destroying anything because it's just a new layer. Now the other cool part with this is because everything is a layer, I can do any changes. This transform is transforming a primitive called hello world. That's the only thing that matters to it. So when you check the layer and how it looks, you will see that the override is just overriding a prim called hello world. That also means that right now my prim hello world, I could decide to change it. I could say, I want now my prim to be another type. Maybe I want it to become a cone. And I will just save my layer A separately from the rest. Let's say I'm an artist working on my asset. I'm gonna save this to disk. And now, if I reload my file, as you can see, my hello world is still transformed, but it's now a cone because the override is still there. So you can see how really flexible that is. It really allows everyone to work together. Those changes in USD, we call them opinions. And when it comes to USD, everything wants to have an opinion. And it's something that you will encounter quite a lot. It becomes really hard sometimes to understand where your changes might come from, because I could have an opinion on this prim hello world in every single layer at any level I want. So that can become really messy. You have to be really structured, but it's also very powerful. Now, the thing that might happen to really fast for you is also the way you make your layer. Because if an artist is working on Hello World and suddenly, for whatever reason, he decides to change the name of his prim, so I'm gonna call it Hello World E, I'm gonna save this. Now what's gonna happen is if I reload the file, you can see I don't have the transform anymore, because the opinion was on the prim Hello World and now it's called Hello World E, so the composition doesn't work anymore. I will explain later the override primitive and the difference with the define primitive, but yeah, just be aware, you have to be careful and you have to be mindful when you do really important change like renaming prim or changing structure, because it might affect any opinions that will come after. Now I'm gonna show you an example that is a little more representative of what you might have to do when you work in a company. So I've done this gorgeous environment where I've published a tree. I've published, here it is. So my tree, I've made USD. In the root, no layers. I've made USD for my terrain. I bring my tree as a reference, I assign some materials, I make an instancer, and on the other end I brought my terrain, put a material, merge them together. I've created an empty Xform prim, grafted it together, and now I have my environment. I can then bring this environment as a reference. I've added a bunch of lights, and we all set up and I have a gorgeous environment. Cool. So that's the kind of thing you would do in a company. You would have different level of assets. Usually we try to not have everything baked basically in the root. You want to use reference, you want to use different assets, etc. Even the instancer would probably be a separate asset, but you know, for the sake of simplicity, let's just say it's fine. Now, the issue we used to have in companies, and just be aware, most companies would have solution for this, but it depends how easy it was to use, is there is always a disconnection between my asset and my shot work. In shot work, you really often have to make something custom, but in the meantime, you don't want to have one asset for each shot. So let's say I wanted to hide some of my trees. What you might want to do is to save a whole new environment just for this change. First of all, it's really not optimized and it's not easy to use. It means you would have to update your environment every time you made a change, etc., for every shot. What's really cool with USD is you don't need to do this, you just need to do a new layer. So you can take your environment, save this as a new layer, override layer, and now what you can do in your shot is you can load your original environment, load the override layer, as you can see, it's just an override, and then put them together. And I have now my change as a separate file basically, but it's not a whole new environment, it's still the original one. And with layer overrides, you can do anything you want. So that's why it's super powerful and it's super easy to work with. Now that's for working into shots, but you can apply the same idea when you work with assets. What I've done here is my tree is one asset at the root, right? But in reality, when you work in studios, you will see that usually the assets are made of multiple layers based on who's working on what part, basically. For example, for my tree, what I can do is if I know already what I'm gonna need, I can create the layer in advance, even though I'm not doing anything to them. So what I've done here is I've created my model for my tree. I'm doing a model layer, but I'm also creating a shader layer that is empty. It doesn't need to have anything. And I'm publishing this as a tree. Now, if I load my tree, you can see I have my tree. It's made of my two layers, the model and the shader. So now what I can do is say, oh, I want to update my shader layer. So I'm gonna dive in here. And in this context, I have my tree here. I'm gonna add materials. So by default, if you check, I don't have anything. I'm gonna add my primitive material. I'm gonna have my material in here. And I'm gonna assign the materials. Now I have a tree with material. If I save this, if you check the result of my previous file now, and I reload the file, I have now my tree as a model with my shader. So as you can see, it's really nice. It's not gonna affect the model layer at all, but if someone wanted to work on the model layer, he will do exactly the same step. So it's cool because it doesn't change the original tree asset. It doesn't change the model. The only thing it's changing is the shader layer. Now, the only thing you have to think about when you do this kind of thing, obviously, is that if someone was changing, for example, the model layer, I would have to update the shading layer if it affects the name of the prim or things like this. But that's just logical when it comes to working together, so it's not really a big issue. Okay, so I just mentioned composition, and it's something that we will come back to a lot during the courses, just because it's really important in USD, because there are so many places where you can have opinion over things through variants, through inherit, through reference, through sublayers, etc. There is an order of strength of what's gonna be taken into account over something else, because if everything has an opinion at the same time, then which one are we supposed to use? To resolve this, we use what's called a liver piece, which is basically stating that local takes over inherits, which takes over variants, reference, payloads, specialize in this order. One way to show you this is that, for example, if I were to go back to my model, I have here my material that is assigned. I don't even need to have a different layer. And here what I've done is I've used what we call inherit to assign materials to. So the result of this is that I have my tree entirely, I can change the color to something, let's say blue. So my entire tree is blue through inherit, so I'm doing this override here. But if I have a direct assignment, as you can see, it's taking over. And it doesn't matter how I merge things together, whatever happens, because this is direct and it's stronger in the liver piece than inherits, it's gonna take over. So it's really important to at least understand why maybe your edit is not happening, it's probably because you have a stronger opinion. Another way to show you this is if I were to assign my material, right now I assign it to mesh, but what happens if I assign to root? Now you can see that suddenly I'm back to the blue, at least for my leaves. And the reason why it's happening is because if I check my leaf, I have an opinion on the leaves directly where I have an opinion on the root, and the leaf opinion is gonna take over the root. Unless, for example, I were to change my strength to stronger than descendant, and now suddenly everything becomes green, even the trunk. So as you can see, opinions, they can be tricky to work with, so don't just be aware why things might be happening. It's probably because you have an opinion somewhere that you didn't know about. So yeah, we will see this more in detail during the courses.